So let's do some examples on predicting products. So predicting products for synthesis reaction. Again, a synthesis, we're going to have two elements. So notice I've got sodium, I've got oxygen, right? So those are my two elements that I have, right? So I'm going to write a compound. So like for a synthesis reaction, essentially you're writing a compound. Name is all you're really doing here. Now, in these spots, so like I'm not going to write the balanced chemical equations out. So if you want to get some extra credit points, you can do those as giving me like the balanced chemical equations. Okay. So if I put sodium with oxygen, I'm going to have sodium oxide because that's a compound that forms between sodium and oxygen. Now, I need to tell what state of matter sodium oxide should be in, right? So I notice here, well, I've got a solid and I've got a gas. Again, thinking back, okay, lower energy always wins out. So which of these two is the lower energy? The solid's the lower energy. So this guy's going to be a solid, okay? That's it. That's me predicting the product. Now from this, I can write a balanced chemical equation from that, right? So that is a predicting products and states example for a synthesis reaction. Again, if you want to write the balanced chemical equation for sodium plus oxygen yields sodium oxide, you are welcome to do it for some extra credit points. Okay. Predicting products for decomposition. So again, as I stated before, you have three types of decomposition that you kind of have to memorize. There's actually more of the different types of decomposition, but we don't actually go into those. So we just do the three. So like binary compounds, carbonates, and chlorates. Those are the three that you need to know, right? So I've got iron 2 sulfide, and I need to figure out, okay, what is iron 2 sulfide going to break up into? So again, decomposition, we've got one compound. So you got one compound. So I've got an iron 3 sulfide. This is my compound, right? So what does this break up into? Well, if it's iron 3 sulfide, it's going to break up into iron and sulfur. So iron. Now notice I dropped the 3 off. The 3 is for when it's in a compound. So when it's in that compound, that's when I have the 3. But when it's just by itself, it doesn't have a charge. So this would be iron. Well, I can look on my periodic table in my classroom and I can say, okay, well, that is a black element. So this would be a solid, right? So solid iron. Plus, well, sulfide is the ion name for sulfur. So the element here is going to be sulfur, and it is also a solid. Okay, so you've got iron 3 sulfide is going to break up into iron and sulfur. So it breaks up into 2 elements. So I've got one compound and it goes to 2 elements. Okay, that's for a binary. So binary, right? My carbonates are a little different. So again, like if you want to write the balanced chemical equation for iron 3 sulfide, yields iron and sulfur, have at it, right? So carbonates. We need to remember that a carbonate is going to break up into something that we breathe out, which is carbon dioxide. Okay, so I need to remember that. So carbonates always form carbon dioxide. So that is definitely going to be one of my products. And I should know that that's a gas, right? I breathe it out every single day. It is a gas. And then I'm going to have another compound here. Okay, so carbonates are going to form 2 compounds, right? So these guys form 2 compounds. So these guys form 2 simple compounds. One of those compounds is carbon dioxide, okay? Now, notice I have sodium. So I can't just have plain sodium. Plain sodium is extremely reactive. It wants to be bound to something else. So this guy is going to form an oxide. So these carbonates form carbon dioxide and a metal oxide. Okay, so my metal here is sodium. So I'm going to form sodium oxide. And this guy is going to be a solid. Okay, just because this guy's a solid, that guy has to be solid. Okay, so always your oxide compounds are going to be solids. So you know that, right? Okay. The third type of decomposition that you can have is a chlorate. Chlorates always form oxygen. So I need to know this, right? So these always form oxygen. Well, oxygen's a gas. So memorize. Carbonates, carbon dioxide, metal oxide. Chlorates, oxygen, and a metal chloride, right? So they form oxygen, and the other thing that they form is a metal chloride. So instead of chlorate, I'm going to chloride, right? So this guy is also going to form another, so like this one is forming a chloride and an element, okay? My metal here is sodium. So sodium is my metal, right? So sodium is my metal. So then I'm forming sodium chloride. And this guy's going to be a solid. So the two compounds that are formed, like that have the metal on the chlorates or the carbonates, those are always going to be solids. So you just know that, okay? The gas that's being released is going to be different for carbonate versus chlorate. Chlorate's going to be oxygen gas, and carbonate's going to be carbon dioxide. Okay, something that you have to memorize. I mean, just memorize it. Okay. All right. So the next type of reaction that we have is a single displacement or a single replacement, whichever one you want to call it, right? You have two different single replacements. So you have it where the element is a metal, and then you have it where the element is a non-metal. So if the element is a metal, you are going to use the activity series to see if the reaction is going to occur. Okay, so the activity series is on the reference sheet. It is in the lower right-hand corner of the reference sheet. So this is the activity series. And what you want to look for is the element that is replacing the element in the compound. And is that element higher than the one that's in the compound? Okay, on the activity series. So I look at this. I've got aluminum and zinc chloride. So aluminum is my metal here, and it's going to try and replace the zinc. Well, I need to make sure before I do this that aluminum is above zinc on the activity series. So you should know that Al is aluminum, zinc is Zn. So aluminum is definitely above zinc. So this is going to occur. So here's my aluminum and here's my zinc, right? So aluminum is higher than zinc. So because of that, this reaction does occur. So these guys kind of form the same thing, right? So like all you are doing is replacing aluminum with zinc. And zinc is coming to be aluminum. The states stay the same. So the element is still going to be a solid, and the compound is still going to be aqueous. Okay, so I'm going to have zinc solid plus aluminum chloride aqueous. Okay, that is predicting products for a single displacement where the element is a metal. If the element is a non-metal, this means it's a halogen. Okay, so like this would be, I would like say that this is just the halogens. If it's a halogen, then you are going to use the periodic table. And down the column is kind of your activity series for the halogens. Okay, so go to my periodic table. I go down. Notice that fluorine can replace anything that's in the row. Chlorine can replace anything below it, but it can't replace fluorine. Bromine can only replace iodine. And then iodine can't replace anything. Okay, so that's like your activity series for your halogens. Okay. Also note, like, Bromine's going to be a liquid, iodine's going to be a solid. So like if I'm replacing iodine in a compound, then it's going to be solid iodine that's forming. And if I'm replacing bromine in a compound, then it's going to be liquid bromine that's forming. So here I have sodium, fluoride, and chlorine. So I need to make sure that chlorine is going to be lower on the periodic table or higher on the periodic table than fluorine. So notice I've got chlorine here, and it's trying to replace the fluorine, the fluoride, and the sodium fluoride. So I go to my periodic table. Well, chlorine is below fluorine, so this reaction doesn't occur. So there is no reaction here. No reaction. I don't have to say anything about it. There's no reaction, okay? Now, if I had sodium chloride and fluorine, that reaction would occur. But because I have sodium fluoride and chlorine, there's no reaction, okay? I've got sodium chloride. This is aqueous plus fluorine. Yes. Well, then this guy's definitely going to replace this guy in that reaction, right? So I'm going to have sodium fluoride, and this is going to be aqueous plus chlorine as a gas. Okay. All right. So predicting products for a combustion reaction, they are always the same. So like this is always a hydrocarbon reacting with oxygen, and it always forms the same compounds, and they are the most common compounds. Okay. You breathe one out every day, carbon dioxide, and you drink one every single day, water. They always form the same compounds. I will tell you that this is a combustion reaction, and you will only be given the hydrocarbon. So for instance, write an equation for the combustion of propane. I give you propane, and I give you the formula for propane. I tell you it's a combustion reaction. So I need to know that I have C3H8. The things that I need to be able to write in for this is that I'm adding oxygen gas to this. It's forming CO2 plus H2O. Because this reaction is so exothermic, because it is so exothermic, it's so hot, your water is not a liquid. It is a gas. And your carbon dioxide is always a gas. So that is your reaction for the combustion of propane. Okay. These are the things that you need to remember. So I need to remember that I'm adding oxygen and carbon dioxide and water are my products. So remember that part.